Okay, I'm going to talk about the results and conclusion and discussion section in the real critical infrastructure. When a network is facing multiple failures, that is okay. For context or for contextualize our presentation, there is a previous word, the sharing trees for protect multicast sessions in 2006, finding failure to join paths in 2010, and some evolutionary algorithms to find that kind of trees in 2005. Okay, remember what is the objective of that RMT, redundant multicast tree. The idea is to find those networks or those trees that reach all the destination with the minimum cost and the highest availability. Okay, the highest availability as possible. What we do, we implemented an SPI algorithm, and SPI is a strength Pareto evolutionary algorithm to find that kind of net and that kind of trees. That is a sketch for our algorithm. We create an initial population. An initial population are evaluated or valid trees for send that kind of information. We select a non-dominated points or non-dominated solution. That solution that are better than somewhere else. And calculate our fitness, how well the solutions that are. After that, select some chromosomes for that group or for that set of solution, cross over of them and mutate them. That is the parameters for our simulation scenario. We run 50 generation with that availability base. It means the variation for availability of one link is between 0.095 to 0.095 plus 5. Yes, that is the variation in our context. The cost is around 80 and 10 and 100, and the mutation rate and the crossover rate is 1% and 3%. Okay, what is our results? In that network, you can see there is a pan-European network, cost 239. We establish a point for create a multicast session and points to consume them. And after that, this is the original tree. And after that, we generate failures into that kind of that session. Our software figure out how to solve or how to resolve new roads when the failures are in the network, and we calculate a second part. Yes, that is an example that what we do. How to analyze that kind of net data? Well, after running each simulation and including a number of failures or a percentage of failures in the network, we can find that that results or that follow that situation. Yes, this is the original one when we don't have any failure, and how the algorithms are figure out networks or figure out trees with that evaluation. That is the availability. Notice when the original one had highest availability, near to 100%, and the lower cost. Yeah, the cost measured in delay or maybe in distance of the links, and the results obtained our running our simulator. Yes, that's what we do. Limitations. Okay, cost 239 is that network, and the NSF net is are very small topologies. That is the problem. And to test the real performance of our implementation is very difficult. For that reason, we create a virtual imaginary topology for testing that. And these results are taken from the virtual one. Yes? Our SPI implementation was tested in a virtual one. Our conclusion, we create or we implement an SPI-based genetic algorithm for the find new RTMs 3s. The SPI heuristic has that complexity, the order to Mn, with M is the number of the links and N is the number of nodes in the network. The mechanisms find highest availability and lowest cost in contrast with the previous algorithm that used only one variable for recalculator for creating their RLTs. This implementation may be a powerful tool for designing reliable networks, even if the network has been deployed yet. That is the problem now with the telecom operator in Colombia, yes? In every place. Future world implementation is the sort of algorithms to generate multiple sessions. Yes, only one session has been generated in our work. Yes, only one. The idea is to generate multiple sessions to experience with bigger and complex topologies. For example, the hot topologies. Hot topologies are hierarchical organized topologies, yes, that kind of graph are I don't know, more similar than the previous or the theoretic one, and new models of failures, maybe in the epidemical failures or diffusion behavior, diffusion, or how to model the diffusion behavior for failures. That is the idea for the future work. Questions?
Yes. Okay. Do you have some features that you like for the hot topology? Maybe the number of the hierarchical levels, and the number of the nodes at each hierarchical level, or if there are cycles, what is the topology that you like at each level, if you are different topologies of each graph? What are the ideal conditions of these hot topologies to test your approach?
Yes, the idea of the hot topology networks has been in the code. There are a low number of nodes, and those nodes are highly connected, with a neighborhood, I think, and that this code is with higher availability and the lower cost. And after that, in a second ring or in a second level, we can find a lot of edge nodes for bringing communication to the consumer, for example. Yes?
Okay.
That is the idea for the test our algorithm in that kind of neighborhood.
Okay.
Okay.
Let me understand if I get this right. After first you select a path.
Oh, okay. No, that part is given. No. Yes, I calculate by the
availability and the cost.
I don't know. They give a grade. Yes.
Then there is some failure in some node.
Okay, some failures no. Our model of making failures is based into things. The first is totally random, yes, and the second one depends on the degree of the node.
What the degree is about the number of links?
The number of links in that node. Yes?
Yeah.
The idea is to attack those links that are more connected.
Then you search another way,
Another
way to around the failure with a
Yes.
genetic algorithm.
That is the idea.
This is not, there is not a lot of computational cost with this approach.
With
But
that,
why to use genetic algorithms?
Okay.
That algorithms are not too
Are expensive.
expensive.
They are expensive, yes.
Okay, that is the idea for that. We choose SPI algorithm. No, we don't have. When we have an SPI algorithm, we only add the set of the best points created in the previous generation. That is the idea. Yeah? What is the idea with that find non-dominated and dominated population, and dominated chromosomes, and dominated chromosomes? The idea is I create a big group of solutions. Yes. I classify that solutions. Yes, and in a multi-objective way, yeah. And the solution that will create the next generation, those are those solutions that are bigger and non-dominated in the previous one, yeah. So we start with a big population, I don't know, 2,100 chromosomes, yeah. And after each generation, calculating the fitness, the strength, and selecting them, we reduce the number of solutions that passes